It's good to see you. Ooh, you got your headphones in and one out. You're multitasking. I appreciate it. You can keep one earbud in if you want. It's a cool look, Kevin. So I am very, very excited because coming up shortly we have the wonderful Craig Beals doing some science experiments live here on stage at the FLIR booth. It's going to be a real fun time. It's going to snow. There's going to be liquid nitrogen. There's also something that you get to interact with at the end. And even more so than that, though, we're also doing a giveaway. We're giving away one FLIR C3, which is a $700 camera. He's excited. Yeah. And then we have two VP50s to give away, and I have a 20% off to give away, which I'm actually going to give away very soon, just to wet your whistle, as they say. That might be a salesman speak. I have no idea. I don't know what I'm doing. I blacked out. Anyway, what I do know is that this booth is fantastic. Just to walk you around a little bit, verbally, there is a FLIR thermal selfie machine back there called the Therminator, so you can take a nice thermal selfie of yourself. There's also a bunch of FLIR products to explore and play with right over there. So look at that handsome gentleman. He'll help you out. There's also an autonomous vehicle that uses FLIR sensing technology to see. It's very fantastic. You can go sit in the car and actually see what the car is seeing. Then one of my favorite parts of this whole booth, is right over there with those gentlemen. It is a VR experience of FLIR City. It is fantastic. It really is a ride. The whole entire machine that you sit in shakes around, dips, dives, dodges. It's fantastic. But you know what else is fantastic? All of you sitting here. Thank you so much. Oh, the cameras are fantastic. And actually, speaking of cameras, here's a transition for you. I want to show you a video of what the FLIR can do. And then after you watch it, I'm going to ask you a question about what we just saw. If you can guess it correctly, you'll win 20% off. Here we go. Ooh, boy, was that mysterious. So, when this worked, you already got the drill down. Just raise your hand. Don't yell at the answer. What was that we just saw? A fuse or a thermal? No, it was not.
The side of the car.
No, it was not the side of a car.
A video.
It was a video. That is, yes, but not where I was going with it. Let me give you a hint, because it was kind of difficult. Even watching it myself, I didn't know the answer. I wouldn't have any idea. It was something breaking in half.
Pencil.
And, what?
Pencil?
A pencil? Oh my gosh. Can you read my mind? It was a pencil. I'm going to frisbee this to you, and let's see how well we do.
Whoa.
That was my bad. That wasn't you. You have wonderful catching hands. My throwing arm is atrocious. So, hi. My name is Jake Roper, as that thing says right there, and I make science videos, generally. And the main thing I focus on is movies, and exploring the science behind them, and using FLIR to help show these very interesting reactions in a very different way. So what I'd like to do, real quick, and by real quick it's 4 minutes long, but just sit through it and deal with it so I feel good about myself, please, thank you very much, is show you a clip from my show, Could You Survive the Movies? This one's all about Back to the Future. I'm going to show you a clip. It's towards the end of the episode, and it also involves Craig Beals, who will be on stage in just a second. I'm going to stop talking. Let's roll the clip. Somebody, Oz, whoever does it. Everything we need is already set up.
Oh, hey, what are you doing? Hey, good afternoon. Oh, thank you to the community. So, yeah, and one applause. So, give that man a point. Thank you for showing up at the FLIR booth. My name is Craig Beals. As you saw, I am a high school science teacher and I should be teaching school right now, but I'm not. I get to hang out with all of you and bring the chemistry classroom right up here to the stage at CES. So this is a really cool thing for me to be able to do these activities with FLIR because I really think science should be fun. I tell my students that if your English class is the most exciting class during the day, as your science teacher, I'm doing something wrong. Because this is the kind of stuff we should be doing to engage our young people, to get them excited about science, technology, engineering, and mathematics, because they're the ones that are going to create all the next generation of stuff that we're going to see at CES. So, instead of listening to me talk the entire time, I want to show you a couple things. On my back, I have strapped 20 pounds of liquid CO2. So it's in a beverage container back there. And I've just hacked apart one of my backpacks. And then I took apart a braided line here and took apart my pressure washer and then added a PVC pipe. And what I'm going to do is pull the trigger and the liquid CO2 should drain out of this tank, go through the tube, go through the handle, and it should, if everything goes well, it should snow right here in Las Vegas. So you can see if you can catch a snowflake on your tongue. Don't try to catch a snowflake in your eyeball, okay? But your tongue is totally okay. Are you ready for this, Las Vegas? Oh yeah, we're gonna make it snow. Unless I screw this up. Here we go, in 3, 2, 1. You see that snow? Look at this guy's like best day ever. Here we go. Yeah! Okay, you guys in the back. That's about as far as I can get it, but I'm gonna come up here a little bit so that you can get snow on as well. Those of you that remember chemistry class, what we've done here, as that liquid turns into a gas, it cools down rapidly, and when it cools down, it freezes the air around it and it freezes the CO2. So right here, you can see it in, maybe not if I turn my hand the right way, we've got dry ice. What we just made was dry ice. I've got a whole bunch of other stuff to show you up here. We're gonna make an even bigger mess than this. While I clean this up and get the next one ready, I want to show you a little more invisible abs. This could be so much fun. This is why we paint our cars, we paint our boats, we paint our bridges, because that reaction is happening, right? But it's really slow. We've sped it up there. And I want to show you a few other things. Now, one of my very favorite things to have in the lab is liquid nitrogen, and especially when we're using thermal cameras, because we can see some great contrast with the hot and with the cold. First thing I want to show you, first thing I want to do is talk about the temperature of liquid nitrogen, because it's quite likely there'll be a quiz at the end. Remember, you're sitting in chemistry class today, and Jake is probably going to come back up at the end, and just a little hint, he always asks if anybody knows the temperature of liquid nitrogen. So I'm going to give it to you now. Liquid nitrogen is negative 320 degrees Fahrenheit, remember that, which is negative 190 degrees Celsius for those of you that live in the real world that all uses the metric system and you're not stuck with us in the Fahrenheit system. So it's cold, it's super cold, and it's turning into a vapor, it's boiling because, well, it's really hot out here for liquid nitrogen. It's 75 degrees or so, so it's turning into a vapor. I'm going to use that to our advantage in a little experiment. So I live in Montana. If you're not familiar with where Montana is, it's north of here, and it's just a suburb south of Canada. So we're basically like South Canada. And there's very few people, lots of cows and lots of mountains. And one of the things we have right out my back door is Yellowstone National Park. Yellowstone National Park is famous for a lot of things. One of those things is Old Faithful Geyser. Anybody been there? A few of you have. Maybe some of you have seen it, at least on TV. So it's a geyser that shoots water up in the air about every 90 minutes. I'm going to bring Old Faithful to you here at the Las Vegas Convention Center, but we're going to do it with liquid nitrogen. So I'm going to put my liquid nitrogen inside the bottle, and then it's still going to be turning into a gas. Okay. There we go. But what I'm going to do is cap it off. But what I'm going to use for a lid, I've got a glass tube here. When I push that in there, the pressure is going to build up inside of here because it's turning into a gas. It's going to push down on the liquid and down on the sides. The liquid's going to have nowhere to go, but hopefully up through the tube, up into the air, where it's going to turn into a gas, and we will have made Old Faithful right here in Las Vegas. Okay, in 3, 2, 1. Yes! Old Faithful, we did it. The Bellagio got nothing on us. See that? Oh man, you don't want that in your eyes. Look at that. There we go, Old Faithful in Las Vegas. Yeah, you're thinking. Okay, good enough. Don't worry, I have more. I want to do something more with that. I want to capture that gas in a balloon. So a little more liquid nitrogen, and you can remind me that liquid nitrogen is how many degrees? Negative 320 Fahrenheit. And those of you in the real world, how many Celsius is? Negative 190, because Jake won't give it to you if you don't say negative. He's a stickler. He's like a teacher. So here we go. Put a little more back in here. And then we're going to capture that gas. Okay? Because I'm going to put a balloon over the top of that. Now, you need to pay attention to what happens because we're going to have the balloons out later. And we're going to do this demonstration pretty much in reverse order. Okay. Liquid nitrogen going back in. They say you're supposed to be careful with this stuff. How you doing? You all right? Okay, so I've got a balloon just with a rubber tube here. I'm going to push that down inside of there, and we're going to see if we can collect the nitrogen gas. Hey, look at there. Balloon's filling up, and it's filling up with the nitrogen gas. Here's the cool thing. If you look at the thermal up there on the screen, you can see right through this balloon almost like it's not there. Because these FLIR thermal cameras see infrared heat, which means the temperature for my body is going right through that balloon, right through that gas, and ending up over there at the camera. Now here's something that would be very foolish. If I took that and turned it upside down, I'm not known for being all too wise. You can see it blew up. That one blew up very quickly. Look at my balloon. It's just going to go back into regular state as it heats up to room temperature, which might take a little while. We'll leave it right up there and you can watch it move. Now, I want to make an even bigger mess. I got to clean this up first so that we can make a big mess up here. I'm going to show you one more thing from Invisible Lab. I love to tell with that, the guy Reggie actually graduated from the high school that I teach at now many, many years ago, and he got thrown out of school for a week for doing burnouts in the parking lot. So when I got a hold of him to come back and do burnouts in the parking lot, he brought his whole family, like the whole extended family came, so he could show them, this is the school, this is the parking lot. I got thrown out of school for doing burnouts, and now they're letting me do it. So that's the benefit of coming from a small town. You know everybody there. Now, I've got an elephant at home, and elephants, pretty much everything's big. Big ears, big feet, big body, big mouths, and with big mouths comes big teeth. And if elephants have big teeth, they need big toothbrushes. And if they have big toothbrushes, you look skeptical. I'm sorry. It's just a story. I'm getting like daggers. Like, okay, I don't have an elephant, all right? I teach high school students and I just come up with stupid stories so that they'll roll their eyes at me as well. But let's say I did have an elephant. You gotta brush the elephant's teeth, right? And if they got big teeth, you gotta have big toothpaste. I've got a couple volunteers that said they'd come up and help me. This is Will and Brandon. Will you give them a hand, please? Look, they've got their safety glasses and their safety gear. I'm going to give them each a pair of gloves to put on there while I sort of talk. We'll have one of you come this side. Will and Brandon run, now you're going to have to help me, video game tournaments in Chicago. So if you're in Chicago and you want to play video games, see these guys afterwards and, we can learn more about their tournaments. I think that's pretty cool. When I was visiting with them earlier, I was talking about my son. He's 7 years old and he was watching somebody play Roblox on YouTube. And I was like, dude, why don't you just play Roblox instead of watching somebody? And he said, Dad, why don't you just go play football instead of watching it on TV? And I was like, okay, yeah, you make a good point. These guys are gonna help me make elephant toothpaste. What we've got here is hydrogen peroxide. Hydrogen peroxide, now listen to this, is H2O2, which sounds an awful lot like H2O, like water, but there's an extra oxygen. We can break that extra oxygen off of there and get a reaction to happen. In fact, it's breaking off of there right now. This is breaking apart into water and oxygen as we speak. But it's really boring because it's really slow. And you remember from chemistry class that you can speed up a reaction with a what? Catalyst. Catalyst? They said catalyst, I'm pretty sure, with a catalyst. So I'm going to use a catalyst to speed up the reaction. I'm going to help have these guys dump it in just a minute. But if we're going to make elephant toothpaste, it's a well-known fact that elephants love cinnamon. So we're going to put it. It's actually food coloring. I don't want it to be mad at me. Okay, we're going to call it cinnamon just for the time being. And it's also a well-known fact that elephants love mint. So I've got some mint over here that we're going to add to it just so it looks nice and pretty when we're all the way done. Okay, next up I'm going to take the potassium iodide. I'm going to add a little bit of water. The potassium iodide is the catalyst. It's a salt, it really is. And then we need some soap so that we have clean teeth. We can put a little bit in there, but if a little's good, yes, you guys, I'm going to get a shirt made and give it to all of you. If a little is good, a lot is better. That's not always the case, but for today it is. Okay, this stuff's wicked dangerous, so just, I'm going to put a little bit in to start. Okay, there you go. And then this stuff's wicked dangerous. Not as dangerous. Then what we're going to do, we're going to count down. We're going to have them both dump it in there at the same time. And then we're going to make elephant toothpaste. Ready, guys? Okay, 3, 2, 1. Right on. Now, so I'm using diluted hydrogen peroxide. They both step back because they know what could happen here if we were in the actual chemistry lab. Here we go. So there's the toothpaste. Now the cool thing is, look at the thermal. It's an exothermic reaction, and you guys all remember from chemistry class that exothermic means it releases heat. You can see the heat coming off of this. So we're making hot elephant toothpaste that's mint and cinnamon flavored, and we did this outside much, much bigger. I want to show that to you next, but if you would give Will and Brandon a hand for being brave and coming up here. Thank you guys. I appreciate it. Take your glasses. Using a whole lot more and using concentrated hydrogen peroxide. There's a reason we didn't do that in here. I think you can tell why. And I want to bring out, we got one more series of things to show you, and these are my favorite ones. Speaking of favorite, would Jake Roper, would you come back out, please? So I hear you. Hi.
Hi,
Jake Roper. Those of you that missed the first part, this is Jake Roper. Jake Roper runs a YouTube channel called Vsauce3. We did a little math on this. There are 1 million people in the state of Montana, okay? Jake's YouTube channel has 4 times as many subscribers as people live in Montana, but it only has 3 times as many as cows that live in Montana. So the cows are catching up on you, be careful. Jake's a fantastic guy. The reason I brought him out here was just hopefully he's willing to be a guinea pig for the next part. Sure. And what we're going to do is have Jake blow up this balloon. Remember I told you when we made the balloon get larger earlier because we captured the gas? I said we can do this in reverse. If we allow Jake to fill up the balloon, we should be able to shrink the balloon back into a small state as we take... You got more in it?
Yeah, sure.
Shrink it back down because your breath is a gas. If you cool that gas down, it will turn into a liquid. Yeah, perfect. It will turn into a liquid, which means, and this may not sound like a good idea, which means we should be able to condense his breath back into a liquid and allow Jake to drink his own breath. Yeah. It sounds like a great idea to me. Yeah, right in there. All right, we're going back to the liquid nitrogen. If I pour the liquid nitrogen over the top, his breath is mostly nitrogen, oxygen. There's carbon dioxide because he was breathing out, and some other things in there. But all of those gases have a lower boiling point, I should say a higher boiling point, than the liquid nitrogen, which means they should turn into a liquid and potentially into a solid. So you can't see it right now, but it's getting smaller, smaller, smaller inside of there. And what I'm going to do, it's kind of struggling.
Help it along.
Yeah.
There you
Full
go.
of hot air, Jake Roper.
Story of my life, Craig.
Okay. All right, you ready for this?
No, but I'm here now.
So I'm going to cut this open and I'm going to dump it into that fine, beautiful crystal glassware. And we're going to, wow. Your breath is something else. Check this out. Look at this. That'll just sit there and spin because it's evaporating and it's, Jake, without further ado, here is your breath.
Thank you very much.
Condensed into a liquid.
Cheers, everybody.
Bottoms up. Tell us what your breath tastes like. Sorry.
I'm gonna cry.
Don't cry.
That was great. Everyone should try that.
Okay.
Once in a while.
So if you get a hold of some liquid nitrogen at home, you can drink. You know what's even better is if you get somebody else to drink your breath. She's like, that's a bad idea. Don't do that. Well, Jake, thank you. If you guys would give him a hand. There is a fine line between bravery and foolishness. I think we have
Crossed it.
We have pretty well found that line. Hey, I don't want to be the only one that gets to have fun, and Jake the only one that gets to have fun. I want you to experience infrared and experience science as well. So what I'm going to do with this leftover liquid nitrogen is do something that I used to do for my dragons. Don't scowl at me again. Back when I was a dragon trainer. But see, dragon training didn't pay well, so I had to get a job at a public school teaching. Some of you know the irony in that joke. But it is a well-known fact that dragons love tricks. I mean, who doesn't? So, dragons breathe fire. They also breathe smoke, but the reason they breathe smoke is not because they breathe fire, it's actually because of their cereal. So that's a little known fact that only dragon trainers and now you know. And what I'm going to do is make a little bit of a mess to start. There we go. And we're going to mix this up, and I'm going to show you why dragons breathe smoke. You know what? I tell you what, if a little's good,
Lots better.
yeah.
Lots better.
You guys would pass my chemistry class. Okay, here we go. I'm going to try it out. The liquid nitrogen should be soaked up into all them yummy bits. Bottoms up. Oh, well. I'm okay. Still okay? That is fantastic. It's like air conditioning for your soul. It's just all up in the inside. Just a little bit more because to drive home the point. I just ate the microphone too. That was weird. Now I want you all to have a chance to try the dragon cereal, get a selfie and everything else. And if you're brave enough to try it, they've got some of these really sweet Invisible Labs with Craig Beals t-shirts over there that they're going to give you to take home, so you can mop your floors and stuff with them. Or you can wear them with pride and say you survived the Invisible Labs and one more day of chemistry class. I really want to thank you, especially those of you here in the Splash Zone, for showing up, for sticking it out, and for learning a little bit with me today. There's a lot of stuff going on at the FLIR booth, really cool things, and I would love to make you some dragon cereal here at the end. So Jake has one last thing, and then I'm going to cook you some cereal.
Well, a big round for Craig. Thank you
thank
so
you.
much, Craig. You are my favorite teacher, so thank you very much. All right, well, Craig has this set up. We're going to do the giveaway.
Yes.
So